There is something huge and immense inside you, an unknown force that accompanies everything and accelerates all galaxies towards the unknown, including our own, the Milky Way. But that's not all. Astronomers may have just found something even bigger. A lot of mystery. What is this unknown force? And will it destroy everything in the universe? Astronomers are very skilled at tracking objects in space, especially with the technology we have today. But this time, we need to look at something outside the Milky Way Galaxy, in the direction of the Centaurus constellation. Constellation Centauri. On this side of the Milky Way. The gas, dust, and stars-filled disk of our galaxy blocks the view from Earth. Astronomers have named this area after them, the Avoidance Zone, or what is called the Great Void, sits deep within that area. With the development of X-rays and radio astronomy, scientists have been able to look into the avoidance area. It turns out our Milky Way Galaxy and the neighboring Andromeda Galaxy, they are moving towards the center of the local group of galaxies, located in the Virgo cluster. All move together towards the Laniakea supercluster center. The attraction area in the middle of this massive mass is the Great Attractor. Its diameter is estimated to be about 300 million light-years, and its center is about 147 million light-years from Earth. Scientists have found in this region behind a cloud of gas and dust, they found a large group of galaxies now known as the Norma cluster. Its total mass Scientists conducting an X-ray study as part of the Galactic Cluster project in the Avoidance Zone discovered something else. They discovered that there are far fewer galaxies in the city. The gravitational pull is stronger than previously thought. It's believed that the mass of the largest attractor is more than 10 million times the mass of the Sun. Researchers found its mass was only a tenth of scientists' original estimate. Most of the visible galaxies in the area are attributed to the Malm Poist bias effect. In space, the farther the distance, the more objects there will be that are hard to discover. Thus, only the brightest objects can be seen. Due to this, we mistakenly associate these objects with areas closer to the sky that they do not belong to. As a result, it seems some areas of space are more densely populated with galaxies. Therefore, the Great Attraction might in many respects be a mirage showing us something that does not exist. It might not be a supercluster at all, but it's just a part of space where there are more galaxies than usual. But the Great Attractor's mass isn't big enough to pull local galaxy clusters. So, what draws them next to the center of the Laniakea supercluster? In search of answers, scientists began to look for a structure of a stronger gravitational force, and soon they succeeded. This is the Shapley supercluster. It consists of about 20 clusters. It consists of 8,000 galaxies located about 650 million light-years away from Earth. This giant contains 10 million, 1 billion solar masses. It is the largest formation at a distance estimated to be 1 billion light-years from the Milky Way Galaxy. Scanning the sky for the oldest cosmic light, the Planck satellite from the European Space Agency, ESA, captured it. Unique photos of the central part of the Shapley supercluster were captured. The largest pink spots show two galaxy clusters. Apple 3558 is on the right. Apple 3562 on the left, plus two smaller groups between them. Scientists also created a model for a structure located in the opposite direction from the supercluster Hyades. astronomers discovered a region with extremely low density known as the dipole repeller. Dipolar repeller. The supercluster Shapley pulled celestial bodies away from this region of space due to its immense gravity. As a result, the dipole repeller might be devoid of matter, because low-density areas in space push matter away as much as dense areas attract it. The bipolar void chaser is related to the flow we also observe, but even discovering the supercluster, Shapley didn't clarify the entire gravity network layout in the Great Attractor region. Professor Matthew Coles from Australian universities believes a part of the Milky Way's speed remains unexplained. The researcher concluded this by calculating the gravitational force of the Virgo cluster, the Great Attractor, and the Shapley supercluster, where it was illogical. It turns out our galaxy must move slower by about 50 kilometers per second, 31 miles per second. Professor Cole believes that the reason for this is due to the mysterious structures hidden behind the Milky Way. Scientists may have already found at least one of them, the supercluster Virgo, where it lies behind a thick lining of dust and gas approximately 850 million light-years from Earth. The mass is considered massive, with a diameter of about 370 million light-years across, and it contains about 100,000 galaxies, and each one shines through hundreds of billions of stars. If its size is confirmed, the supercluster could be the largest cluster adjacent to the Milky Way Galaxy. The gravity of the supercluster Virgo might explain the discrepancy between the actual speed of the Milky Way Galaxy and that resulting from the expansion of the universe. Meanwhile, astronomers have studied 883 galaxies in the void region, where a third of them were never observed before. The research was conducted using the Parkes Radio Telescope in Australia. First, scientists were able to find 3 concentrations in the galaxies, NW1, NW2, and NW3. Then 2 new groups, CW1 and CW2. On average, each galaxy contains 100 billion stars. Discovering hundreds of galaxies beyond ours means an incredible amount of mass was unknown to scientists, and its gravity might influence the speed of surrounding galaxies' movement. But even this does not end the mystery. The Milky Way Galaxy still moves faster than it should. Scientists are still searching for the sources of the anomaly. In addition to uncovering the nature of the Milky Way's movement and the movements of other local group galaxies, there is one idea that dark matter may be involved here. Its invisible groups can attract galaxies with gravity like that of the massive structures of ordinary matter. Galaxies might accelerate due to another theoretical force of the universe, the dark flow. This is the name given to the unexpected movement of galactic clusters, often towards an unknown mass outside the visible universe. Scientists from the Goddard Space Flight Center discovered NASA. Signs of this phenomenon were detected through analyzing data from the Wilkinson Microwave Anisotropy Probe on more than 1,000 groups, and this is a very extensive study covering a significant part of the visible universe. The authors of the paper mentioned that the dark flow extends
Dive deeper into the
more
speech.
than previously thought. That is, 2.5 billion light-years away from our solar system, heading towards the Great Attractor near Centaurus and Hydra. According to one theory, this mysterious dark flow is linked to another dimension of a hypothetical multiverse.
It is assumed that our universe
Is the
originated...
mother bubble one of the primary energy range? And if that's the case, Many universes could have formed from other bubbles. The dark flow might have originated due to the gravitational pull of a mass from a parallel universe. Scientists study this theory in reality because there's ongoing debate about it. Meanwhile, an international team of astronomers conducted an interesting study related to the Great Attractor. They observed the movements of 10,000 galaxies and their clusters within 350 million light-years from Earth. Scientists have been tracking the movement of galaxies that began when the universe was 1.5 billion years old up to the present day. They calculated the paths of galaxies starting from the Milky Way based on their current brightness and their location in space. Based on the results, the researchers compiled an interactive model showing the Great Attractor near the Virgo mass, the Perseus supercluster adjacent to Perseus Spike A. The model illustrates how individual clusters and galaxies move towards the center of attraction. But most importantly, scientists have calculated the future of each of these celestial bodies, including the Milky Way Galaxy. They found that the accelerating expansion of the universe would prevent most cluster groups from moving to gravity centers. Even scientists have compiled a future interactive simulation of galaxy paths in this region. The model extends from an era of early galaxy formation to a time when the universe will be twice its current age. Simulations show that only a few major mergers happen in particularly dense clusters. It will occur in the next 10 billion years. Right now, we know that space is a big mystery, and often answers lead to more questions. What are the other extraordinary space phenomena you would like to hear about? Let us know in the comments, and make sure to stay updated for more amazing discoveries and unbelievable things, the events that occur in our world. Thank you for watching.